Hi everyone, Caoimhin here from MTU's Blackrock Castle Observatory. In this video we are going to be taking a look at some more colliding and interacting galaxies. If you haven't seen our Twitter video from earlier this week, it shows you how to find one of these interacting galaxies in the sky. But just before we get into those galaxies, we're going to watch the moon set as it comes down after the sun and the objects that are going along with it. So there's Venus very much underneath the moon, still quite close to the sunset. It will get more visible as we move further into the future. There's Mercury, getting less visible now as we move later into the month. And above the moon, there's Mars. So if you've got the right time and a clear enough horizon, there are 4 planets all in a row. Well, 3 planets plus the moon, 4 objects that you can see all in the row with your naked eye over the coming few days. Of course, Mercury is going to drop out of view reasonably quickly. Mercury does move quite fast. So the sun is setting. We're here at 10 o'clock. We can already start to see Corvus, which is the constellation we use to locate one of the interacting galaxies. So galaxies are moving through space just like everything else. And if 2 galaxies are close enough together, their gravity can propel them even closer together. Now, of course, the universe is expanding based on everything that we can tell, but whatever force, it may be dark matter or dark energy, whatever force is causing the universe to expand, it's not quite stronger than gravity at short distances. So 2 galaxies very close together, their gravity can attract them closer and closer until they really pass through each other. And that's kind of what we're seeing here with the antenna galaxies. Their mutual centers of gravity is distorting the shape of the galaxies. They're losing a lot of gas here, but it's pulling them into eventually one larger galaxy. So here's another interacting galaxy. Unfortunately, this one, I don't believe it has an image attached. It doesn't. I'm only labeling the interacting galaxies here. So this is a couple of useful services that Stellarium provides. So in our sky and viewing options, we can mark different catalogs. So I know that Able and the European Southern Observatories, they've caught a lot of interacting galaxies. We can filter so that we're only seeing those interacting galaxies. You can filter by various different things. You can use various different catalogs, but different catalogs do look often for different objects as well. So, Messier, a lot of easy to see things. European Southern Observatories, a lot of those things will be looking into the southern sky. So we can use these things to help us find particularly interesting objects. We can also search for objects. We can just search for an object if you happen to know its a name or number off the top of your head. But there are also these lists, various ones. We've got interacting galaxies here, but there are those bipolar planetary nebulae, active galaxies, various things. And it will give us a list of them. So there's the antenna galaxies that we just took a look at in Corvus. Here are some in the Able catalogue. And if we go down, there's plenty in the European Southern Observatory catalogue as well. So we can see if a few of these have images, and of course a few of them won't. We're looking at things that are often quite far away here. This one doesn't have a distance set on it, so Stellarium at least doesn't know exactly how far away that interacting galaxy is. Now we don't have an image of that, and we're not able to see it even with a telescope here because it is very, very faint. This is at 15 on the magnitude scale. The bigger the number, the fainter it is, and the harder it's going to be to see. You can see it's also reduced by air masses. In previous videos, we've mentioned that objects are often easier to see if you're looking at them higher up in the sky. And this is something we can actually demonstrate with a star like Spica. Spica is very, very bright. It's here less than 1. It's only a 0.95 on the magnitude scale. It's a very bright star. But it's reduced to 1.24, 1 and 1.25 by these air masses. Now, as Spica moves through the sky, the amount of air masses it's passing through changes. When it's really, really high, pretty much at its peak, it's passing through fewer air masses. There we go. As it starts to come down the other side, getting lower in the sky, it'll be coming through more air masses. So that can make stars appear fainter, and it can change how they appear, even just depending on what latitude you're at. Here in Ireland, Spica will never really look as bright for us as it can for people who are living closer to the equator and therefore see it higher in the sky. So that can have an effect on what we're actually able to see. Now, most of these interacting galaxies, which just have names and numbers, they're going to be some of the ones that are harder to see. They're often ones that are further away. With proper names like these, we're more likely to find something that's actually got an image in Stellarium, although it's not guaranteed. When these objects have names, it usually means that they've been known about for longer, that they've been talked about more. Very often, we don't want to use these crazy lists of numbers to talk about things. So if it's something that's talked about very, very regularly, if it's something that's quite well known, it's usually going to get some sort of name attached to it. Now, I know a lot of members of the IC catalogue are a little bit closer, but still not close enough to have a good image on them. So I'm going to do a search for a particular set of interacting galaxies, which may not be above the horizon at the moment. There we go, the mice galaxies. Now, last I checked, these did have an attached image. There we go, very far away, but there it is. And this is a really good example of an interacting galaxy because you can see one of them here still kind of has its arms. It's still got an indication of that spiral shape. And this has a lot to do with galactic evolution. So galaxies, they're very big, they move quite slowly, they change quite slowly, but they do change and interact over time. So what we believe happens based on the different types of galaxies that we can see is that spiral galaxies being medium to large in size, we've got a few, some of them quite distorted over here. Those galaxies are a little bit smaller, and when they get attracted together, they lose this lovely spiral shape and become elliptical or lenticular galaxies, those big balls of stars. We can see some of them in the direction of the constellation of Virgo. Now, I don't know if that, well, it's not going to be labeled because it's not an interacting galaxy, but that seems like an elliptical or lenticular galaxy to me. They are gigantic. They're the biggest type of galaxy that we see. They're much larger than most of our spiral galaxies. So what we believe is happening with the mice galaxies, with the antennae galaxies, is that two spiral galaxies are colliding, and as their shapes get distorted, as they stretch out like this, like the antennae galaxies, and then recombine, they form these larger elliptical galaxies. So interacting galaxies, they're a really, really interesting thing to spot. Of course, they do take a telescope, but even if you don't have a telescope, we've got those lovely views of the planets over the next few days as well, and those are more than visible with the naked eye. And if you are in a dark enough sky, you might be able to catch the Andromeda Galaxy with your naked eye. Now, the Andromeda Galaxy, it's not quite an interacting galaxy yet, but it certainly will be once we give it a significantly longer amount of time. The Andromeda Galaxy and the Milky Way, we will become very similar to the Antennae Galaxy and to the mice galaxies, because the Milky Way Galaxy and the Andromeda Galaxy, we're going to collide. So here's everything back. We can see everything again. There's the Andromeda Galaxy just above this shed. The Andromeda Galaxy is still quite far away. Its shape isn't distorted, neither is the Milky Way. We're still both nice and spiral. But as the two galaxies get closer together, they will essentially pass through each other. There's a lot of empty space between stars, so it's almost like two clouds colliding, and then the shape of those clouds changing. So even though it's very far in the future, so we don't really have to worry anyway, there's probably not too much need to worry about the Milky Way colliding with Andromeda. There's a good chance we will be perfectly safe, and the most likely thing to change is that the glow of the Milky Way, this line that we see in the sky, it could change its shape and spread across the sky. So even though we won't be around to see it and there's no need to worry, rather than worrying, we might be maybe a little disappointed that we won't get to see the show. But hopefully you will get to see some interacting galaxies and some planets over the coming days.